Let's graph some exponential functions using transformations. Below is the graph of y equals e to the x. Transform it to make the graph of y equals the opposite of e to the x minus 6. Give the range and domain of this new function using interval notation. The first thing I'm going to do is I'm going to transform this one step at a time. So if I read this part here, e to the x minus 6, let me point to that. That minus 6 here means transform your x values to the right 6 units. To the right 6 units. So why do I write an intermediate transformation in blue? I'm going to take this blue dot here and move this 6 units to the right. 1, 2, 3, 4, 5, 6. I'm going to plot a dot right here, which is 6, 1. 6, 1, we have a dot. And we could actually draw a very similar exponential function. Now this is not the final answer. What we now have to do is take this dotted line and apply this next transformation, which is this opposite symbol. This says take every y value and make it its opposite. So I'm going to take this one here and I'm going to reflect this across the x-axis. So this was a positive y value, and now it says take its opposite. So it's going to reflect down here. So now it's going to be what? Well, I'm going to plot a point or ordered pair at 6, negative 1. Negative 1. And we're going to do the same thing for all the y values on that dotted blue function. So I'm going to do something like that. And right about here is our final answer. So right here, this says y is equal to the opposite of e to the x minus 6. Let's try the next one. This time, we once again have the graph y equals e to the x here. I'm going to do its justice by putting the arrows to indicate the domain and range. Those arrows are supposed to be there. We want to transform this e to the x graph so that we can graph y is equal to e to the opposite of x plus 2. This time, I'm going to transform this part first. How do we transform the opposite of x? That means for all the x values here, we're going to reflect this about the y-axis. We're going to reflect that about the y-axis. So why don't I draw right about here and reflect this way. So this one here, if you're wondering what this is y is equal to e to the opposite of x. It's a different y. You can call it y hat if you want. I forgot to tell you what this one was. On the previous example, do you know this one? This one was y hat is equal to e to the x minus 6 in the previous example. Back to example B. Now we just got to add 2 units to all these little blue dots here. It says move all these y values up 2 units. Move all these y values here up 2 units. So the simplest one to move would actually be the y-intercept. So this is 0, 1. Let's move this to what? 0, 3. And I'm going to plot a red dot. That means your horizontal asymptote also moved. Your horizontal asymptote was right here. So this was y equals 0. This is going to move as well. This is now going to move to this part, which is y equals 2. And now we're in good shape. We can actually draw our exponential function, and it approaches that horizontal asymptote. So the red function is what we want. This red one is actually y is equal to e to the opposite of x plus 2. Make sure you label its horizontal asymptote. That is necessary. Make sure you draw that in. This one down here, I should say the same. I should also label its horizontal asymptote. This one is actually y equals 0. I'm going to draw that in. And so the HA here is y equals 0. And that's how you could graph using the transformations on the function y equals e to the x.